All right, so this question is basically you have a parameterized curve, parameterized by these 2 points here. And we want to find if you draw a tangent at any point, apparently it'll come back and hit the curve at another point. We've got to show what the coordinate of that point is. All right, so I'll say that one more time. If we have a tangent, then this tangent, apparently at any point on that curve, will intersect it again at a different point. So it's not going to be the same point. It's going to be a different point. And the point will be in this ratio to the point where the tangent was from, apparently. That would be pretty cool if we could show that. And we can. Okay, so y dash, it's going to be y dot over x dot, with respect to t. That's fine, that's just going to be 3t squared plus 1 over 2t. I think we all got that bit. All right, now we're just going to use the equation for the tangent. I'm assuming you've seen this equation before, where y1 is just your y coordinate, x1 is just your x coordinate, that's the gradient. So I'm just going to substitute everything in. It's pretty standard work so far. And we have x minus t squared. Okay, so that's my tangent. That's the equation of it. It's a straight line. It looks like that. I could make this tidier. In fact, I will in a second. But let's just stop and think. We know that this line will come back and hit the curve. At what coordinates? Well, we want to find those coordinates in terms of t, little t. But we know that that they're on the curve, so they must be parameterized as so. Just like every other point in the curve, just with a different parameter, right? So we're just going to substitute this in and work out what this parameter is in terms of the old parameter, right? So we got, t squared, 2 plus 1. I'm going to bring that 2t up at this point. So this 2t here, I'm just going to multiply on the left-hand side by that as well. Just make things a little bit neater so we can see what's going on. And that's going to be equal to 3t squared plus 1. I'll need to scroll over just a little here to fit everything in. And that's going to be capital T squared minus small t squared. So what is this equation? This equation is a cubic in t. So it's a cubic in capital T. And we know that, therefore, it has 3 roots, right? Which makes a lot of sense because 2 of those roots are t, small t, because this is a tangent to the curve at that point. So we know that a tangent will have a repeated root. So basically, the question we're asking, if we try and solve this equation for capital T, we should get t as small t as an answer twice. And by the factor theorem, or in other words, you could think about it, that just means that capital T minus small t squared must be a factor of this cubic. So I'm a big fan of doing that in one chunk. So I just wanna get all the let's write it as a polynomial in t, and let's try and do that as nicely as we can. Okay. So that's bringing t squared over. Right, how much t have we got? Well, I mean, it just looks like we have this much t. And if we find our constant, how are we going to do that? Well, that's a little trickier. So we have this thing, minus 2t squared. I'm going to be adding this also multiplied by t squared. So I'm going to be adding t squared times this guy. All right, so what have we got? What is our constant? Well, it looks like once we add that, we're going to get t to the 4. Then if we subtract 2t squared and add t squared, it just looks like we're subtracting t squared. So I think that should be our constant, right? And of course, I'll write that as this. Don't know if I want to do the difference of 2 squares or not yet, but it's possible. Okay, but I mean, let's not get sidetracked. The main point is that we want to find t. We want to find this guy, and we know that capital T minus t squared is a factor, right? So all we got to do is, well, factor this guy out. Okay, so let's try to do that. And I'm just gonna do that off the bat. So we know we're gonna have this. Actually, not as hard as it may seem. So that multiplied by something will give the equation above. Okay, but that something, well, I mean, how much, you know, in order to get this much t cubed, the only way I can do that is if I multiply by 2t. 2t like that. Okay, now all I gotta do is check the t squared terms. All right, well, how much t squared am I getting already? I'm getting minus 4 small t squared from what I have so far, right? But what I actually want is I want minus 3t squared, and then I'm going to add a 1 to that. So in order to do that, well, I mean, I guess all I need to do there is add on, it looks like add on a t squared, and add on a 1, I think. Oh no, subtract a 1, yeah, because, you know, that's going to be a minus t squared. And just stop and look at that for a second, and you'll actually find out that works perfectly. Hopefully. I mean, hopefully it does. I mean, let's just check. I mean, the t squared and this will give you your constant term. We just need to then verify that, I guess, the coordinates of the t's are the same. So, you know, you can do that, but I'm not going to, because I have faith. I have mathematical faith here. So that's what that's gonna be when we factor that out, right? Which is good, because if we look at that, that's 1 minus t squared over 2t. The answer actually pops straight out from setting this to be 0, right? So that's t is just going to be moving that the other side, exactly minus 1t squared over 2t. How do I know that? Because I know that t is not t. So the only solution is this guy. All right. So that's good. There's just one more thing that we need to do. We need to show that that free t squared is not 1. Well, I guess what you could say is, suppose it was 1. And there's a couple of things, a couple of ways you can do this. You can, I guess, go back to the equation and say, well, then the coefficient of this is 0, and that leads to bad things. What I ended up trying was, well, if 3t squared was 1, we'll look at this 1 here, right? Or even look at that 1 here. Now, if you set that equal to 3t squared, you'll find out that is actually the same as saying t is t, and that's not good. I mean, that's why it's not 1, right? Actually, yeah. Now I've just realized by doing this video that makes perfect sense, right? If 3t squared was 1, this answer is actually the same thing as saying that t is t, which is bad, right? Because again, we don't want the point to be the same. So the only way 1 minus t squared over 2t is equal to t is if 3t squared is 1. Well, we do not want it to be equal to t, okay? So, yay, we did that. That wasn't actually as bad as I first thought. It could have been tricky, but there you go. Right, so, given a point p0 in the curve with this sequence, so let's do the next bit. So, whoops, drop my pen. Okay, so we're given a point p0 with parameter t0, sequence of points, and we see that basically we're going to use what we just did, right? So we're going to do this in such a way where we take the tangent to a general point, and then find out the next point that it hits, and then draw a tangent to that, find the next point that it hits, draw a tangent to that, find the next point that it hits. Okay. So couple of things to know. What do they want us to do? Well, they've given us a value for t naught. Now you should be thinking tan. What's tan got to do with anything? And you'll see in a second it does. Right? I mean, if we spot this, the first thing that jumped out at me was this looked quite familiar. This 1 minus t squared over 2t. Because I know that 2 tan theta over 1 minus t tan squared theta. I know that that's actually tan 2 theta. So I see that this thing here is similar. Okay, it's very similar, right? So we know that our next point basically there, if we're given t naught, I know that or not just t naught, but let's say ti plus 1 is gonna be 1 minus ti squared all over 2ti. Right. Now if we stop for a second and we say ti is tan of, I don't know, theta I, let's say. So we can rewrite it as that, right? I mean, I don't see why not. You know, for some value of theta, as long as we're careful and specify theta to be in a certain range. So I guess I could do this. Yeah. So yeah, and then let's just do that. Well, we see that ti plus 1. Well, that's just another way of saying tan now of theta I plus 1, and we saw that was actually just 1 over tan of 2 theta I. Now, in order to make any further progress in this question in any significant manner, you need to know a identity. You need to recognize that that 1 over tan of alpha is actually gets pi over 2 minus tan of alpha. Or no, this. Yeah, that wouldn't make any sense. What am I talking about? Okay, so that's like a common, well-known identity, but it also makes a lot of sense if you think about it. Think about tan and what it's doing as it's going to 90. It's becoming asymptotic, and we know that it's kind of a weird symmetry about pi over 4, because that's when tan is 1. So this identity makes sense, but you know, if you haven't seen it before, you can prove it just by explaining it out or whatever. But that's really important to know here, because then we end up getting this relationship. Tan of theta I plus 1 is equal to tan of pi over 2 minus 2 theta I, and that basically is the trick to allow us to do the rest of the question, right? Now we want to show that if t naught is tan of 7 pi over 18, then we want to show that t3, you know, is going to be the same as t naught. So, you know, if t naught is 7 pi over 18, we'll plug it in that relationship. 7 pi over 18 was theta naught in this case. So what's theta 1? Well, I mean, within reason, there's a lot of ways you can do this, but I mean, just by considering thetas as I'm going to do them right now, we can do it this way. So we have pi over 2. We're going to subtract 14 over 18. Right? So that, in other words, that's how many 18ths is that? It's 9 pi over 18 minus 14 over 18. Now it's just going to give me minus 5. It's minus 5 pi over 18. But, you know, I would prefer to write that differently. So what I can do is I can add pi to that. So it'll turn out to be, you know, another way of writing that is 13 pi over 18. Okay, so that's theta 1. And then, you know, it's pretty nice work from here once we've spotted those two identities. Like, not much else to it. So that's again 9 over 18 minus 26 pi over 18, working out to be what's that? I can just about do maths. I think that's minus 17 pi over 18, or in other words, you know, that's just pi over 18 again, multiplied by 2 pi. So theta 2 is pi over 18 And I mean, yeah, we can see that theta free is just going to be pi over 2. So that's 9 pi over 2 minus twice that. So it's just going to be, yeah, 7 pi over 18. Okay. So we have shown that, you know, if theta represents that, then tan of theta represents a point, and it's all the same, really. So that's good. Tick, tick, and we see clearly that theta one's different. So that's how you would really do that. Right, and then I actually struggled. I struggled at this bit. Find a second value of t naught, for which p3 equals p1, but the first point isn't the same. And I Skyped my friend to ask about this particular one, and he was baffled too. And we ended up stewing in the problem for 10 minutes before we finally realized that if A goes to B, goes to C, goes to A, and A has period 3, well, what's another thing that has period 3? Well, it's either B or C, right? And then we came to this realization and just started laughing for about 2 minutes, because literally we spent 10 minutes scratching our heads at this problem. But of course, another value of t naught would be using this theta or using this theta. That's like a 1 mark answer, you know? And if you didn't get that problem, hopefully you found that humorous as well. And if you did, you're probably laughing at me going, "What an idiot!" Well, I didn't really care. I'm quite an idiot at times, so I found that quite humorous anyway. So yeah, that wraps that question up. Would I have got this in the exam? Gonna be honest with you, I don't know, because my maths, I don't know how good it is at the minute. I don't know if I could be at that level again, but you know, that factorizing, just stopping and thinking before jumping in with the algebraic swamp definitely is beneficial. You know, realizing that actually the t minus t squared factored out, that saves you a lot of algebra. And I tried it without that, and it just took ages. I cried a little, and it sucked. So yeah, always take the time to think, is there a better way to do this question? So this is Chris. This was step 3, 2003 question 4, and I hope you found that helpful. Cheers.